Okay. So, we have been looking at this program called PAM, which basically reasons about goals and plans and actions of people and tries to understand stories which involve goals and plans and things like that. And we have seen that it works in 3 phases: the predictive mode, the bottom up mode and the incorporation mode. So, let us look at this algorithm in a little bit more detail. So, if you look at the predictive component, you can see that that is the first one which tries to explain the new input essentially. So, the predictive component has access to a number of previous predictions made by PAM, and a prediction is basically a condition part of a rule that PAM guessed would be important essentially. The predictive component serially matches all the predictions that it has with the input that it is seeing, and if a prediction is confirmed or it matches, then the rule is passed on to the incorporation component along with any inferences that it may have made. PAM also keeps track of goals being fulfilled, and we will look at this in some detail later. But if no prediction is matched, it passes up control to the bottom up component essentially. So, what a bottom up component do is that it generates plausible explanations for inputs. It has a large collection of rules which are kind of its long term memory. These rules are PAM's knowledge of people's intentions. These rules are indexed using a discrimination net or something like a Rayleigh net, if you have looked at it before, but it makes those inferences in a test mode, because it is possible that you may think that this is action, this is a plan for this action of which this action is a part and this is a goal and so on, but it could not necessarily be correct essentially. So, it may have to backtrack and try something else. So, while it is doing this inferences, it does not make any changes in the story representation. Those story representation changes will be made only in the incorporation mode, which will be invoked only after the predictive mode has succeeded. So, till the time when the predictive mode succeeds, PAM sort of cycles through predictive mode and bottom up mode essentially. If it at any point cannot find a rule, then PAM will have to fail essentially. When the prediction is confirmed, then the incorporation mode is called. So, the prediction could be confirmed either by the input or by an inference made from the input by the bottom up component. Then the incorporation component integrates the input and the inferences into the story representation. It takes as input the sequence of rules that led to the matched prediction from the bottom up fold, and it uses those rules again and adds the inferences one by one to the story. After that, it removes the predictions that are no longer needed, including the one that was met, because that has already been met, and generates new predictions. So, that is the way it operates, and we will look at this by a small animation that I have created. Then it passes control to the predictive component essentially. So, after it has understood a part of a story, then it goes to the next part of the story. So, let us say that at some stage PAM has read about an action and is trying to figure out what is happening. Now, it needs to always have some set of predictions in its memory, and in this example there are 3 of them, as you can see. So, prediction is the condition part of a rule essentially. Okay. I think I have done this. Okay. So, the prediction is a condition part of a rule that is part of PAM's memory, and it has something which it calls its focus, and which is called as the input gap. Gap is basically a term used by this group essentially. So, it places that action that it has seen into that input gap or into its focus, and tries to match it with all the different predictions that it has, which are basically the pattern side of the action essentially. So, let us say that the prediction does not match, then it will invoke the bottom up component and try to explain or try to find a plan which is an explanation for this action. Remember, plans are explanations for actions and goals are explanations for plans essentially. So, it does this by always putting the stuff that it is trying to match into this thing called input gap. It is basically some location and it always matches the predictions with whatever is in that gap essentially. So, when it is come into the bottom up mode, it was not expecting to hear about an action, let us say. So, it needs to find out what possible plans this action could have been a part of essentially. So, in the bottom up mode, this action could have more than one plans. So, let us say it has 3 plans that it could have been a part of, and it will try these options one by one to see if it eventually infers something which matches the prediction. So, its goal is to try to match a prediction, and in the bottom up mode it will produce something and try to see whether it was expected. So, in this case it takes the first of those plans and puts it into the input gap, this thing, and then goes through the predictive mode essentially. Again it will try to see whether one of those 3 patterns that it had in its memory matches the input pattern essentially. So, the bottom up modes generates these inferences and gives them to the predictive mode. The predictive mode tries to match whether what it has been generated is what was something that it was looking for, and what is it looking for are those 3 patterns you can see at the top of the slide essentially. So, it matches with them one by one, and let us say that this plan 1 also does not match any of those patterns. So, it goes back to the bottom up mode and now tries to find out an explanation for this plan 1 essentially. So, it is doing, you can see, depth first like search here. It generates a goal for that plan and it will put this goal into the input gap. Again the process is that if you are looking at something that was not predicted, can you infer something in the bottom up mode that could have been predicted. So, in this case it is goal 1, it goes to the predictive component, and see that goal 1 is an explanation for plan 1, which is an explanation for the action, is what you started looking at essentially. So, it has gone into this predictive mode, it tries the 3 patterns one by one, and let us say that again it fails, and so it has to go back to the bottom up mode. So, it will try to generate an inference from this goal 1 essentially. Again let us say that this goal 1 has no more inferences that it can make. So, it will have to backtrack and try the second plan, which is plan 2. So, doing in this depth first fashion that it is working here. So, it takes this plan 2 and puts it into the input gap and repeats the process, goes to the predictive mode, tries to match the pattern one by one, the 3 patterns, to see if that plan 2 was part of them, and let us say that it does not match again. So, it goes back to the bottom up mode and says that no, this plan is not matched, but is there a goal which is an explanation for this plan which will match. So, it gets this goal 2 here, puts it into the input gap, goes into the predictive mode, tries matching them one by one, the 3 patterns with the goal, and let us say it fails again, it has to go back to the bottom up mode. So, it will try to find some plan for which this goal could have been a sub plan for. So, let us say that there are 3 possible plans, this goal could have been a sub goal for that plan, and it takes this first of them, which is plan 2.1, and pastes it into the index. So, this process is, you can see, it basically doing a sequence of inferences and trying to see whether that is something that it matched or not essentially. It tries these 3 things, and let us say at some point it succeeds, that one of the predictions was indeed looking for a plan for doing something. So, it goes now into the incorporation mode essentially. So, it has some story which has already built so far, starting with some theme, goal x, plan x, goal y, plan y, and goal z, and so on. Then this new part, this action that it heard about and the explanation that it generated, that this action was part of plan 2, which was part of goal 2, which was part of plan 2.1. It makes those inferences again, but this time it knows that they will succeed. So, it adds it to the storyline, and it has finished with this incorporation phase. At this point it will remove some of those predictions and add some new predictions. So, in this case it has added some predictions which it will expect to hear in the next part of the story essentially. So, it will go back to the predictive mode and see whether the next thing is this thing. So, let us look at another example with this thing in mind. So, let us say that John was hungry, which is a state, and actor Hume 0 is in the hunger value is -3. It cannot explain states. So, it goes to the bottom up mode, and yeah, going a bit too fast. So, let me slow it down a bit somehow. Yeah. So, it has got a rule called a hunger rule, which says that if an actor is hungry, then it will try to look for a plan for satisfying that hunger, and the source for this goal is the hunger drive, which says that basically people are generally hungry essentially. So, it will place this now into this input gap, and it has got two gaps of its own that we just saw, that we are looking for a planner and that we are looking for a plan. So, these are the expectations that it will have. So, it sees whether this goal of satisfying hunger is something that it was expecting. So, it turns out that it meets an expectation because the goal is derived from a theme. The expectation is met in the sense that you always expect people to be hungry at some point or the other. So, you do not have to explain that goal any further by trying to say why was he hungry or something like that. The explanation is that people are often hungry. So, it is a way of stopping that inference process, and so it goes into the incorporation mode, which is that it fires the hunger rule again, and it also takes the suggestion. So, PAM used to call these requests as suggestions, and all these are terms for rules. So, it takes the suggestions stored with the rule and adds them as requests in the style done by Ellie in Riesbeck. So, what is the process it has done? It has said that the goal of being hungry is explained by the fact that people are generally hungry, and then you should set sorry. So, it takes the information stored with this hunger rule, and this hunger rule has this other kind of directive stored with it, which says which are kind of like suggestions to PAM, which says that try to fill the plan gap in the plan. So, there is a plan and there is this plan gap. So, set target is equal to plan and try to fill the plan gap of that goal, and look in the input gap. So, input gap is where it expects to see everything new, either the input or something which is inferred essentially, and try to see whether you are finding a suitable plan for satisfying this hunger essentially. So, check in the list of plans for satisfying the goal of hunger and see if what you are looking at is a plan for satisfying this hunger essentially. So, that is a suggestion which is stored along with the hunger rule, and when PAM incorporates this as part of the story, that yes, John was hungry and people are generally hungry. So, maybe there is a plan that he will have of satisfying his hunger, and that the planner should be the one who will fill this this gap for the planner. So, for the planner, look for the focus on the actor of whatever actions that you see, and recognize that the action that actor is the planner in this plan. So, remember that there are these two gaps in this one. One is the that you are looking for a plan, and then that you are looking for a planner essentially for this goal for satisfying hunger. So, essentially PAM knows that it is going to look for a suitable plan, and it is going to look for somebody who is executing that plan. So, requests or suggestions, they always have a focus essentially, the place to look for information essentially. So, focus on the input gap or focus on the actor, and that is where you will get the information. A request is considered only if its focus gets new data. A request is, remember, a rule essentially. So, it is a rule which PAM has instantiated, but it will be considered only when its condition is satisfied. Then requests have a focus, and they also have a target, which is where the new information will be generated. And then they have activation conditions as to when is the request to be activated, and the target and the focus are set when it is activated essentially. So, the moment you activate a request, you know where to look for the information and where to make the inference essentially, or where to add the inference essentially. And they would typically be used for situations like role merge that we saw when we were looking at scripts essentially. So, there would be a request which says that if you see an actor, then this actor is the same actor as that. So, PAM has been looking at this story, and it is got this story that that there is a goal of satisfying hunger for which there must be a planner, which it immediately finds, because you know that it is John who is hungry. So, it fills in, it is filled in by the request immediately, and then it makes a prediction that I will look for a plan for hunger. So, it is trying to fill the plan gap. So, prediction is that that there is a plan for satisfying hunger, which should be placed in the plan gap essentially. So, the input is the focus for this request. So, look at the input to see if you are hearing about a plan to satisfy hunger, and if you find it, then put it in this plan gap. Plan gap is that brackets just after the plan in this thing, and it goes into the incorporation component. So, it knows that there is a goal of satisfying hunger. It knows that the planner for that whatever happens is John, but it does not know what the plan is as of now, and it says that look for a plan for that. So, it has created a prediction, as you can see in the format that we had discussed. A prediction basically looks like condition action, and condition is the prediction that you are looking for, and the action would be to place it in the plan gap essentially. So, that it adds after the incorporation component. The next sentence it hears is that he ate at a restaurant. So, a very simple story, something that you could write on Twitter for example. The input is an action. So, this is a kind of action we have not really discussed, but doing a script is also a kind of an action. So, he ate at a restaurant can be thought of as an action, but it was looking for a plan for satisfying hunger, and it sees an action of eating in a restaurant. It still has to make that connection that the action of eating at a restaurant is part of a plan of satisfying hunger essentially. So, it goes into this bottom up mode and says that here is this action that we have seen. So, it has got this rule which is called do restaurant plan rule, which says that if somebody is going to a restaurant, then maybe it is a plan for going to a restaurant essentially. So, if somebody has gone to a restaurant, it is a plan for which is part of a plan box of going to a restaurant. So, it is part of a plan. So, it takes this inferred plan box or plan and places it in the bottom up component, the same process that we have been looking at, and sees whether it matches an expectation. So, remember that it was looking for a plan for satisfying hunger. So, in the predictive component, this plan for hunger matches this plan box of going to a restaurant, and so it has succeeded in matching a prediction. and it will go into an incorporation mode essentially. So, the restaurant plan is in fact the plan for satisfying hunger, it goes to into incorporation mode. So, along with this plan box, you can see that there are many gaps in the plan box. There is a planner is needed, actions are needed, a restaurant is needed, and maybe some sub episodes are needed. He went to the counter, he went to the cashier, he sat at the table, all that things that happen inside a script can be expected to be here about. So, PAM has created all this. Remember, this is the incorporation phase. So, it has said that the target of the planner, which is this gap, should be filled by looking at the customer in the script. So, whoever was the customer of the script is a should go into this place here essentially. So, that is it creates a rule. So, PAM explicitly creates and instantiates rules and sets trigger conditions for them essentially. So, then it says that for the target restaurant of plan box. So, there is this other target, set the focus on the restaurant of the script. So, whatever is the restaurant in the script that you are talking about is something that should go and fill in there essentially. And essentially it says that for all the actions, keep looking at whatever you are focusing at and you will find some actions. So, this is for the target actions, which is this another gap in this essentially. So, it started with this goal that John was hungry, then it is found that it has a plan box of going to the restaurant, this thing for which it is got these 3 requests sitting out there saying that it should fill in some of those gaps, and the action that it has seen is that John went to the restaurant. So, it has filled up those details, and then there are these requests which are waiting there. So, we do not know some of these things, which was the restaurant and what are the actions he did there and so on and so forth. But PAM is sitting there with these expectations saying that you will hear something about this, something about if the story had continued. So, this was a very short story, we are going to end it here, but if the story had continued, then PAM would have been saying that okay, I need to fill some of those gaps, and maybe what you are hearing about is in those gaps essentially. So, I just wanted to illustrate how PAM works essentially. So, one of the mechanisms that PAM uses is this device of creating request chains. So, requests are normally activated only when their focus gets new data. So, for example, if this is a focus, then it may add something to a new gap, which may be the focus of another request and so on and so forth. So, in this example, there is a request like this. So, this is the focus and this is the target of this particular request. So, the target of this first request could be a focus for the second request, who will have a target, who could be a focus, which could be a focus for the third request and so on and so forth. So, it can basically set up this request chains to transmit information. As it understands stories, it will know that okay, the customer of the restaurant is the actor of the plan and that kind of stuff essentially. So, it uses this mechanism extensively. So, as soon as something comes into this first focus, it will get transmitted to the others essentially. So, this business about success and failure, remember that whenever we are talking about this John's desire to get Bill's bicycle or John's desire to satisfy his hunger and so on and so forth. So, the moment we see that there is a plan box which has got some sub episodes and that is a focus of this request in black here, then that information will get transmitted to the plan essentially. Then there are these plan success rules, which says that if the plan has succeeded, then the goal has succeeded. So, so when Bill handed over the bicycle to John, then John's goal of getting hold of Bill's bicycle also succeeded essentially. So, these request chains are basically used to disseminate information within the story representation itself essentially. So, if you know that this plan succeeded, then the goal succeeded. So, PAM actively adds and removes requests. When do you remove a request? So, a request that has outlived its usefulness should be removed, lest it fire by chance later, and it will also save on the processing time, because you don't have to keep polling the different requests otherwise. Any program does not have to keep looking at the focus. So, requests are attached to their focus gaps essentially. So, whenever a gap is filled, any request that is fired which was focused on that gap can be removed, because it has done its job. If a request fills a gap, then all requests targeted at that gap are also removed, because that gap has been filled essentially. So, what was the plan that you were looking for satisfying hunger, or what did, how did John manage to get Bill's by. So, if there is a gap which has been filled by some request, then you have already done the job. And if a request fills a gap that will not be filled again, then all requests which are focused on that gap can be removed after testing, because after, if the gap is not going to be changed again, either those requests can fire now or they can fire later essentially. So, focus, target and setting up request chains and removing requests are the mechanism they use for maintaining relevant rules only and firing them at appropriate times essentially. So, it is a very carefully crafted system essentially, that when you know this, you update this and so on and so forth, and then keep removing such connections as you go along. So, here is a request activation in a flowchart form. So, when a gap changes, you see whether there is a request focused on So, when a gap changes, you see whether there is a request focused on the gap essentially. So, if there are requests which were waiting for information to come into that gap, then for each of those requests you test whether the condition of that request is true, whether whatever, for example, did the plan succeed or did the plan fail. So, it must, so the plan succeed rule will say that if the plan has succeeded, then say that the goal has succeeded. The plan failed would say that if the plan has failed, then say that the goal has failed. And so, there would be a condition, you test that condition and activate that request. So, you fill the attached gap by action of the request and activate the suggested request, remove the requests which are attached to the filled gap, and test the gap filled by the action of the request essentially. So, you keep doing this in a cycle essentially till you are finished essentially. Okay, I think so. With that, we will end our discussion on PAM. We started looking at PAM after we were looking at SAM, which was the script apply mechanism, and we were looking at SAM because it was a way of talking about frames and how frames were used. This whole work from Yale University that we were looking at, starting with conceptual dependency, scripts, then goals, plans and actions, was entirely focused towards understanding stories essentially. So, what the group did was demonstrated that you need a considerable amount of knowledge in a system to make sense of natural language stories essentially. And we came to PAM because we found that scripts were inadequate, in the sense that they could understand certain simple kind of stories which involve stereotypical situations. But if you want to talk about actions of people as to why did this person do this or why did this person do that, then you need the kind of knowledge which relates goals of people to plans of people to actions of people essentially about intentions of people. So, we will end this part of the exploration here, and in the next class we will go back to the logical way of looking at things. So, we have seen that frames allow you to do things like inheritance and talking about subtype relations and so on, but frames do not impose any logical constraints on your representations. You are allowed to say, for example, that Delhi is in Canada and nothing will stop you from there essentially. In the next class, we will try to look at something which is called description logic, which tries to establish these taxonomies or inheritance hierarchies purely on the basis of description of concepts. So, we look at a language for describing concepts, which will allow us to automatically decide as to what that is a relation or instance of relation is, without having to specify it explicitly by us essentially. So, our descriptions will logically entail some of those relations. So, we will look at description logic, which is a very popular topic nowadays, because it is connected with ontologies which are connected with the semantic web, which is the new generation web and all this kind of stuff.